Whenever you have two objects or two forces pulling on a single object, there's a bit of a competition about who's going to win. Now, you've done questions where something is pulling to the left and something is pulling to the right, and that's not too difficult to figure out because they're pulling directly opposed to each other, so whoever's pulling stronger wins. And then you can get an acceleration from there. But in a situation like this, I have the blue character pulling off that way at 400 newtons, and I have the green character pulling off this way at 600. Now, this one is pulling a little bit up, but also a little bit left. And this one is pulling up, but a little bit right. And so I think we can agree that whatever this object is, if it moves, it will move up, but will it drift left? Will it drift right? Or are they perfectly balanced so that it doesn't drift anywhere, it just goes straight up? In order to do that, I have to look at each of these vectors independently, and I have to decide how much this one is going left and how much it is going up. So I'm going to redraw the triangle for you. I'm going to redraw the force for you, and then you will see that it's a triangle. So I have 400 newtons going that way. It's 400 long. And it has a piece going this way that is leftward. And I have a piece going that way, which is rightward. So some in X and some in Y. And I have a 30-degree angle down here. Now I'm just going to use some basic trigonometry in order to figure this out. X and Y meet at a 90-degree angle. So all I really need is SOHCAHTOA. I'm going to write that up here. That's a little nonsense word for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So if I want to find out how much of this force is pulling to the left, I'm after this thing. So that's adjacent to my 30 degrees. So if I use cosine 30, cosines are adjacents over hypotenuses. I get something like that. So if I pop the 400 up to this side, all I have to do is park that in a calculator. So I'm going to make sure I'm in degrees and then do 30 cosine times 400 gives me 346.41 newtons. Okay, now I'm going to do the same thing for y. Y is opposite of the 30, so instead of using cosine, I'm going to use sine. And sines are, according to this, an opposite over hypotenuse. So 400 sine 30 should give me Vy. So Vy is sine 30 sine times 400 gives me 200 newtons. That's there. Okay, so this force here, this 400 newtons, that thing is a pull upwards at 200 and a leftward pull of 346.41. What I've done there is I've broken this force, this combined force, into components. A vertical component and a horizontal component. Component is just a word that means ingredients or things that make it up. So I've taken a force that was drawn on there at an angle and I've decided how much of it is horizontal and how much of it is vertical. If I did that to the green one, I'd have the amount of it that's upward and I'd have the amount of it that was rightward, and then I would be able to see how much force is going that way and I'd be able to see how much force is dragging to the right. So I'm going to take a minute to do that. Switch to my green marker, draw this vector at a 45-degree angle. It has a little piece to the right and a little piece up. So again, this x is adjacent to the 45, so I'm going to use my cosine. Cos 45 is Vx over, how big is this? Oh, this one's 600. So Vx, if I pop that up, will be 600 cos 45, which gives me 45 cos times 600. It's 424.26 newtons. All right, and if I do the opposite side for vertical, I'll need sine. Sine 45 is opposite over hypotenuse. That's Vy over 600. Vy, if that comes up, would be 600 sine 45. So Vy is 45 sine times 600 is 424.26. It took me a minute there because I got the same number. That happens at 45 degrees, and only at 45 degrees, but you get the same number. Okay, so this 600 newtons from the green character is providing a horizontal force of 424. And a vertical force of 424.26. I guess I should include the 0.26 there. Okay, so net. So that means add them all together. If I were to look at this, I have a horizontal force that way and a horizontal force that way that are going to fight each other, one's to the left, one's to the right. So I'm going to have to get that information onto my answer here somewhere. And then I'm going to have forces that are vertical, and I'm going to have to keep them separate from the horizontal ones. And you've done this before. If you have information that's horizontal and information that's vertical, and you want to keep them separate, you write them as an ordered pair. So the horizontal, I can see that the green one's rightward pull is going to beat the blue one's leftward pull. So I just have to figure out how much it beats it by. So this minus this, 424.26, subtract 346.41, gives me 77.85 in the horizontal direction. Okay. Now, in the vertical direction, they aren't fighting each other, they're helping, right? They're both pulling upwards. So this force plus this one, plus because they're helping, subtract because they're not. 424 plus 200 will be 624.26. Okay. So that's lovely, but I don't know how to put that on my diagram. So I took two forces that were not in components, and I got an answer that was. Now that's a bit rude. If you're handed something not in components, then you should not give components back as your answer. So I'm going to reconstruct this thing. What this is a net force that's heading to the right, 77.85, and it's heading up at 624.26. And I want to know this. I want to know the net force if I combine those two things. So hopefully you see a right-hand triangle there, and hopefully you'll remember that you can solve the length of a hypotenuse in that with Pythagorean theorem. So c squared is a squared plus b squared. So my legs are 77.8 squared plus 624.26 squared. 7785 times itself gives me 6061.26, and 624.26 squared gives me, oh goodness, 3897.55. All right, if I add those together, get 39561.81 and square root to get my C. I get 629.0. Now that rounds to 1.0. So if I take this 400 Newton force and I add this 600 Newton force together, what I end up with is a force of 629 Newtons. So this person here, they came to help, but because there's so much spread between the two people trying to pull whatever this object is, that their force, even though it's pretty big, isn't helping very much. So I've got this force I can toss onto the diagram. I just need to know where to orient it. So that requires this angle here. And for this angle, I have an opposite over an adjacent. And I've used sine, I've used cosine. So the only one I haven't used is tan. And look at that. Tan requires opposites and adjacents. So I'm going to use tan to recombine this. So tan of this Mr. angle, I'm going to use alpha for the Mr. angle, will be the opposite side, 624.26, over the adjacent side, 77.8. So I'm going to have to toss tan across the equal sign, which makes it arctan, and 624.26 divided by 77.8 gives me 8.023. 24 if it rounds. And if I hit tan backwards, I get 82.9 degrees. So my net force then, notice how it's here tipped up, is almost vertical, but not quite. 82.9 degrees. And it is 629.1 newtons. So this object is going to drift a little bit towards the 600 newton character. And it's going to be pulled harder than 600 newtons, but not so hard as the two of them added together. When you go to do the practice problems, they are phrased using a particular apparatus that you may or may not have access to. And so the questions ask, how much force would you have to apply in order to balance these two things? And so the answer to that, after doing all of this work, is that if the blue one is pulling that way at 400 at that angle, and the 600 is pulling that way at that angle, they together behave like this. So the force that's required to balance them has to be pointed in exactly the opposite way of their net force. Hopefully that lined up. If it's 82.9 degrees from that way, it'll be 82.9 degrees from here. And the size of this has to match the size of this. So if I put this force at that angle and this force at that angle, they together pull like this pink one. But if I hung a third one on this yellow string that was that size at that angle, this pull would exactly neutralize those two pulls, and this object wouldn't be able to drift. So the problem sets will require a little bit of explaining once you have the apparatus in front of you. If not, you can always send me an email and I'll try and clarify for you. Okay. Good luck.